Introduction to Solar Photovoltaic, or PV for short. This video is going to be a very brief overview of how modern PV systems work and how to interact with our grid. In later sections, we will go into each part in detail. You will start with what a grid-tied PV system is actually made of. Most grid-tied PV systems are composed of the following. There will be some type of racking system to either make a standalone structure or to fasten the support structure to a roof and permanently secure the solar panels. Then there's the solar panels, which are connected to the pluggable connectors called MC4s. There is usually a kind of junction box to provide a waterproof way to transition from solar wire to conduit and to provide a safe place to house overcorrect protection, a rapid shutdown system, or a combiner panel if necessary. Next is the conduit. The conduit provides protection for the wires that connect the array to the inverters, as well as connecting the inverter to the service power. The inverter is the heart of the system. It has a very important job of constantly turning DC solar power into clean, usable AC grid power. Sometimes there will be one single inverter, and other times each solar panel will have its own inverter. Most of the time you will have a DC disconnect built into the inverter. The AC disconnect is simply a way to shut down the system by breaking the connection between the inverter and the grid. Wherever there is electricity, there will have to be an easy and convenient way to shut it down. And lastly, there has to be some means of interconnection to the grid. Common forms are a dedicated solar breaker in the main service panel or a line side tap. That is basically what a grid-tied PV system is made of. There are a lot of details involved with each step, but it is good to start with a general idea of the whole subject, then start learning the details, so you're not wondering how something applies to what you're learning. This is how solar actually interacts with our grid. On a small scale, grid-tied solar is very simple. Think of it as having your own mini power plant on your roof. The solar power is fed into the house's power, powers the loads that are on, and sends the rest out to the grid. The power that is sent out to the grid is tracked by a bidirectional meter, which is a meter that can track the power that you use and the power that you send back. Different places have different policies, so you will have to ask your local power company or go to their website and look for something called the Net Metering Agreement. There are common types of solar PV. Grid-tied, which is what we just went over, just solar panels, inverters, and grid power, no need for batteries, usually has the best return on investment but will not work if the grid power turns off. Grid-tied battery backup is a bit different. Sort of like a backup generator, you will have a separate protected load panel for all of the loads that you will want to work with when the grid power goes out. The solar power comes in and charges a battery bank, which is regulated by a charge controller. The battery inverter uses the battery power to make a usable grid power, which will then supply the power to your protected load panel, then send the rest back to the grid. In the event that the solar can't charge up the batteries, the inverter can act as a charge controller and use the grid power to charge the batteries. Off-grid is sort of the same as a battery backup system, except, you guessed it, no grid power. Instead of sending excess power back to the grid, the charge controllers will just not allow the solar to make extra power. When the state of charge on the batteries gets too low, a generator will automatically kick in and bring the batteries back up to a specified state of charge. Here is an example of a super simple off-grid system. The solar panel collects solar energy to charge the battery, which is regulated by the charge controller. Then the battery inverter uses the power from the battery to create usable AC power. What helped me learn this is if you were to disconnect the solar and charge controller and only have the battery and inverter, the inverter will still make power. This is called a DC coupled system. The solar energy does not directly power the inverter, but it goes to the batteries first. There are also AC coupled systems and hybrids of all the above, but for now we will just focus on just getting the fundamentals of solar down so you can build a solid understanding of grid-tied solar design. To sum this section up, the DC electricity from the solar panels goes through an inverter to convert it into usable AC power. The inverter feeds the converted solar power to your house's power supply, either in the main service panel via a breaker or through the line side tap. You are still 100% on the grid when you have grid-tied solar. No need for batteries unless you want battery backup. Off-grid solar is almost completely different in design when compared to a grid-tied solar. In the next section, we will go over the basics of solar panels and inverters. After that, we will jump right in and start designing our first grid-tied PV system.